Hey guys, welcome back to my channel. This is the Cortex and we are back at it again. This time I am covering the first chapter of physics, physical quantities and measurements. I will be breaking this into two parts, so make sure to see the other part. The things we'll learn in this is physical and derived quantities, SI units and its prefixes, standard form and or notation. See, these are all the topics we will cover, but in this video we will cover till parallax and zero error. Now first we need to know what are physical quantities. A physical quantity is a quantity that can be measured. It consists of a numerical magnitude and a unit. Now what is a magnitude? Now the number or the value is the magnitude, and the unit, like we know, or the SI unit, which we all should know, is the unit like kg, meter, kilogram, you should say, second, ampere. Altogether there are 7 basic quantities: length, mass, time, electric current, thermodynamic temperature, amount of substance and luminous intensity. Now you see this table, we see length has its SI base unit as meter and it has symbol of M. Same with electric current, it has the SI name of ampere and the symbol of capital A. Now we will have to learn all of these because these are very important: length, mass, time, electric current, thermodynamic temperature, amount of substance and luminous intensity. We also have to learn their names and their symbols. Now what are derived quantities? Derived quantities are quantities that are calculated from 2 or more measurements. Derived quantities cannot be measured directly. They can only be computed, which means they need a proper equation. No instrument can measure them because they need a proper equation. We see over here, these are the different derived quantities. Let's check area. The symbol has capital A, and these will always have a relationship with the base quantities because area is length multiplied by length, and it has a derived unit of meter square, and its unit in SI base unit is meter square. Now what you will have to learn is the derived quantity, symbol, the derived unit and SI unit. And I don't think that relationship with base quantities you will have to learn, but over time we will cover all of these formulas, so you will learn all of these formulas as well. It will take time, but it is easy. Now the main question is, why do we need SI units? What is the importance of this? Can we work without this? Well, these are very important. SI unit, this is the French version of it. I do not know how to spell it, but in English it is known as International System of Units. This is the same in the whole world. The SI system is important in science and technology because it provides a consistent and coherent system of units for all physical quantities derived from a few base units. This means that you do not need to use any sort of conversion factor between different units. This makes it very easy actually, because these units are used in the whole world. It has this unity. We do not have to again and again convert this. So that makes it really important. Now this is a very important thing, the prefixes for SI units. We will not go into much detail in the deca and hecto, but you will have to remember kilo, mega, giga and tera, but not more than that. And along with this, you should know what is deci, centi, milli, micro and nano. The last are not so important, and you will have to remember these numbers of each and every one of them, and symbols and prefixes obviously because they link together, of mega, giga, tera and kilo, and deci, centi, milli, micro and nano. Now this we have heard a lot. What is standard form? Standard form seems very intimidating towards people, but it is not intimidating. It's actually very easy. Standard form is the way of writing numbers where one integer is multiplied by an appropriate power of 10. What does that mean? That one number is multiplied by an appropriate power of 10, which when it is solved, it gives the same value. The standard form is a way of writing down very large numbers or very small numbers easily. For example, 103 equals that. So 400 multiplied by 103 equals to this, because we can see there is a so 4000 can be written as 4 multiplied by 10 to the power 3, because it has 3 zeros and they can be summed up as 10 to the power 3. If you will be solving this, so the same value will come, 4000. This idea can be used to write even larger numbers down easily in standard form. Larger numbers and smaller numbers, they are easily summed up by this. This covers the same point what I have shown over here. Now standard form, now this is, as I told you, it's very important. This is the basic rule. A number should always be written with one integer before the decimal. We see over here that these numbers, one integer, so how many decimal places should I change? 1, 2, 3, 4, 5. So simply I'll put a decimal over here and write 5 over here, and same with this 1, 2, 3. So because we are going in the other direction, we will have to write -3. Now you should know how to do this. And kg into microgram. Now you should merge the ideas of standard form and the prefixes. Just to remind you, kg is 10 to the power 3 and micro is 10 to the power -6. Pause the video and drop the answers down in the comments. I'll be showing you the answer right now. 1, 2, 3. This is the answer. As you can see, we will obviously first convert this into this, but people might be asking, why does this happen? Why is it not 10 to the power -6? People might ask. See, this is the justification. 1 microgram equals to 10 to the power -6 grams. This says that 1 gram will obviously be equal to 1 upon 10 to the power -6. If you know the rules of indices, you know that when denominator is changed into the numerator, it will lose its negative charge on the power. So that's what happened here, and this is our value. See, this is a huge value. To sum it up, we use standard form. This is a very important part of this lecture or topic. You would say it's the measurement of length. Now you might think that measurement of length, that is very easy, but it has to be very accurate. People make a lot of mistakes during this. The standard unit of length is meter, the SI unit you would say. But being a small unit, we refer to big units to make measurement simple, like kilogram. Some examples of units are: height is measured in foot and inches. Meter rule can be measure lengths up to 1 meter, obviously, because 1 meter rule. We all know that. Tape measure. I have written these two because these are the two basic instruments of measuring length in our syllabus. The steel tape is used to measure straight long distances, usually over 1 meter. Now, why straight long distances? Because steel is not as bendable as cloth tape measure, which is used to measure distances along curved surface, like a cylinder, for example. And see, this is very important. If a ruler is broken, find the value of the reading. To find the reading, subtract the final value of the reading from the first value of the reading. See over here, the first value of reading, when we want to measure this scissor the pair of scissors, we see that the first reading is 5 centimeters and the second reading is 14. What it says, 14 minus 5 is 9 centimeters. So now we know that the length of these scissors are 9 centimeters. So you should know how to do that. Precision and accuracy. Accuracy refers to the closeness of a measured value to a standard or known value. Now, what you might be confused, but I am pretty sure if you see this picture you should know. Accuracy means the standard value, like the bullseye is the standard value of this dartboard, and it shows that the person who is shooting it, or the instrument which he uses, is accurate. Whereas precision refers to the closeness of two or more measurements to each other. To be precise, the smallest unit in an instrument can measure, that's precision. So you see in the dartboard, the person or the instrument is hitting the same point again and again, so we say the instrument or the person is precise. This is a very important thing. Parallax error. Now you might have heard about this, but you should remember the definition. The error / displacement caused in the apparent position of the object due to the viewing angle that is other than the angle that is perpendicular to the object. This basically says that the line of sight which we see over here is not perpendicular to the division, you could say. It is not perpendicular to the object basically, so that will give a wrong reading. You see this person who is seeing, he interprets it as 4.7 and he is interpreting it as 4.9. that makes it wrong, because we need to get a precise value. You see, his line of sight is perpendicular to the object, to the division. It is 4.8. And this is also very important, the zero error. We will be discussing it more in our second part, where we will learn about vernier calipers and micrometers. The zero error is a technical term, which means how far away from zero is the reading of the instrument when the real value is known to be zero. It can be either positive or negative. We see these values. Now zero error, see these divisions are not matching, which means there is an error in this. Thank you, it has been a pleasure. Though this is the start of my channel, I would like to thank all of you. My channel is growing slowly but surely. Bye bye.